Example 2. Determine the total distance traveled by the particle in example 1. So in example 1, we determined the final position, but we didn't really care about where the particle was in between, if it moved forwards or backwards. So in this one, total distance is not the ending position. It's more to be thought of how much ground I covered. So in order to find total distance, what we need to do is we're going to integrate from A to B. So we're the same idea as before. We're going to integrate, but we're going to integrate the absolute value of t dt. Notice that the starting point does not matter, since we're not looking for the end position. We're only looking for the displacement of how much ground I covered over a certain amount of time. So what putting the absolute value does is it gives us a graph that looks something like this. The original graph would have covered this negative distance and then this positive distance, and we would subtract them. By taking the absolute value, we're only finding positive values, which the integral is going to add together. This value right here is x equals 1.25, or s equals, or t equals, whatever the x-axis was. So at that time is when the particle stops moving backwards and begins to move forward. So to do this on a calculator, we do the integral from 0 to 5 of the absolute value of t squared minus 8 divided by t plus 1 squared dt. And then all you have to do is type that in your calculator using Math 9, and you're going to get 42.586, and that's how much distance our particle covered. Now, if we want to do it by hand, it is possible. But to do this, we have to determine the intervals so that we're only guaranteed a positive value. So we did this something like this back in chapter 6, where we did the absolute value of the integral from 0 to 1.25 of t squared minus 8 over t plus 1 squared dt, plus the absolute value of the integral of 1.25 to 5 of t squared minus 8 over t plus 1 squared dt. Now you're welcome to do that by hand, but it's a little tedious. It is doable, it's just a little tedious, where you'd find the absolute value of this area down here and then add it to the absolute value of the other portion of the graph. So now what I want you to do on your own is determine the total distance traveled over the interval from 0 to 2 pi with the velocity function 5 cosine of t. So here we go. We take the integral from 0 to 2 pi of the absolute value of 5 cosine of t dt. Put that in a calculator, and you're going to end up getting 20. Again, notice the starting position does not matter when we determine total distance instead of final position. So a little summary of what we've just done. Integrating velocity gives displacement, and displacement is the net area between velocity curve and the time axis. Integrating the absolute value of velocity gives total distance, which is the total area between the velocity curve and the time axis. So integrating velocity gives displacement. Integrating the absolute value gives total distance traveled.